Hello, Assalamualaikum and greeting to all my classmates and especially to our lecturer, Sir Petrus. So today our group will present presentation 2 for DJJ52012 Engineering Plan Technology. So our group consists by 4 people: Muhammad Nizam bin Amran 07 DKM 19F 2011, Fung Chun Leong 07 DKM 19F 2007, Rafiq Iqmal bin Anis Isham 07 DKM 19F 2023, and also myself Muhammad Dekwan bin Asnain 07 DKM 19F 2033. So for presentation 2, these are our question we get. Before we go through, I will start with an introduction. A gas turbine, also called a combustion turbine, is a type of continuous and internal combustion engine. The main element common to all gas turbine engines are an upstream rotating gas compressor, combustor, and downstream turbine on the same shaft as the compressor. Next slide is explain the working principle for regenerator, intercooler, and reheater. Analyze the diagram for different gas turbine system equipment layout. So we start with regenerator. So these are the regenerator diagram. Regenerator recover the waste heat from exhaust gas of the gas turbine. Majority of power plant use waste heat recovery cycle for improving the efficiency of the cycle. In gas power plant, the waste heat from exhaust gas of turbine pass through the regenerator. Next, intercooler. For intercooler, these are the diagram. Intercooler is a mechanical device used to cool the incoming air on an engine fitted with forced induction, either a turbocharger or supercharger system. The intercooler job is to cool the air after it has been compressed by a turbo or supercharger. The last one is reheater. So these are, as you can see, these are the diagram of reheater. Reheater is a part of the boiler which to reheat steam output from the first level of the steam turbine. Reheated steam will again absorb the heat energy from the boiler to be used in the next level steam turbine. So reheater is one way to improve the thermal efficiency of the Rankine cycle. So next is different gas turbine system equipment layout. For this different gas turbine, they are divided by two: open cycle and closed cycle. Open cycle is a combustion turbine plant that is fired up using liquid fuel for rotating a generator so that electricity can be produced, while the closed cycle is a turbine in which the temperature and pressure of the atmosphere air that enter the compressor are increased.
Determine the schematic flow process diagram. Compressor. Air compressor used in a gas turbine power plant in mainly of the rotary type. The air filter is attached at the inlet of the compressor where air gets filtered from gas. The rotary blades attached to the shaft push the air between stationary blocks, and consequently the pressure of the air is increased. High pressure air is available at the outlet of the compressor. Next is regenerator. There is always some heat present in the exhaust gases in a gas turbine power plant. A portion of this heat is utilized in the regenerator. In regenerator, there is a net of fine tubes. The compressed air is passed through these fine tubes. The whole arrangement is enclosed in a vessel through which hot exhaust gases from turbine pass. During passing through the fine tubes, compressed air gets a portion of heat carried by exhaust gases. In this way, a significant portion of the heat of exhaust gases rises the temperature of the compressed air before it enters into the combustion chamber. Combustion chamber. After passing through the regenerator, the hot compressed air enters into the combustion chamber. In the combustion chamber, there are burners through which fuel oil is injected in the form of oil spray. Due to combustion of this hot oil spray inside the combustion chamber, the air attains a very high temperature. The temperature is about 3000 degrees Fahrenheit. The compressed air mixed with combustion gases then cool down to 1500 degree Fahrenheit to 1300 degree Fahrenheit before it is being delivered to the turbine for doing mechanical work.
Hello, my name is Muhammad Nizam bin Amran. My matrix number is 07 DKM 19F 2011. Now I want to illustrate about the pressure versus volume diagram. The generator. Pressure versus volume diagram of generative gas turbine open with NC compressors and NT turbines. Points label S lie on isentropic davits. Point label T lie on isotherm TA for the compressor and on isotherm TC for the turbine. Point not label pertain to the realistic case in which there are isentropic uses. PET K1 T2KS and J1 T2JS are adiabatic process for the compressor and turbine, respectively. Paths K1, T to K, and J1, T to J are the corresponding realistic process which account for the isentropic losses. As a consequence of the regenerative heat exchange, the heater operates between state X and C. The next is intercooler. Intercooling also involves the use of a heat exchange, and intercooler is a heat exchange that cools compressor gas during the compression process. For instance, if the compressor consists of a high pressure unit and a low pressure unit, the intercooler can be mounted between them to cool the flow and decrease the work necessary for compression in the high pressure compressor. The cooling fluid could be atmospheric air and water. The net work output of a given gas turbine is increased with a well designed intercooler. Studies of gas turbine equipped with extensive turbine, convective, and film cooling show that intercooling can also allow increases in the thermal efficiency by providing cooling fluid at lower temperature, thereby allowing increased turbine internal temperatures. Last one is reheater. Reheating, as shown in figure C, occurs in the turbine and increases turbine work without changing compressor work or exceeding the material temperature limits in the turbine. If a gas turbine has a high pressure turbine and a low pressure turbine, a reheater, as shown in figure C, usually another combustor, can be used to reheat the flow between the two turbines. Reheat in a jet engine is accomplished by adding an afterburn gun at the turbine exhaust, thereby increasing thrust with a greatly increased fuel consumption.
For this slide, I'm gonna explain about illustrate the temperature versus the entropy diagram T minus S. Okay, reheat and intercooling are complementary with the heat generation. By itself, they would not necessarily increase the thermal efficiency. However, the intercooling or reheat is used in conjunction with the heat generation. A significant increase in thermal efficiency can be achieved, and the network of output is also can be achieved. This requires a gas turbine with the two stages and a compression of the two turbine or stage. That's all from me, and thank you.